You've made this cake 100 times. You know the recipe by heart. So why does it come out different every single time? Here's the truth. Almost everything you think you know about baking is a rumor. Passed down from a grandmother, a cooking show, a blog you skimmed once at midnight, and most of it is just wrong. Fact number 1. Room temperature butter doesn't actually matter. It's just an old habit. People assume any softened butter works the same, so they microwave it into a puddle to save time. It sounds harmless. Butter is butter, right? But butter at exactly the right temperature is a structural ingredient, not just a flavor. Here's the reveal. When butter is cool but pliable, sugar crystals cut tiny air pockets into it as you beat them together. And those pockets are what make a cake rise and a cookie stay tender. Butter that's melted or greasy can't hold that structure at all. King Arthur Baking's own bakers test for this with a simple finger press, not a clock. So next time a recipe says room temperature, don't eyeball it, press it. Your cookies are quietly asking for a specific texture, not just a warm stick of fat. Fact number 2. Sifting flour is a pointless old-fashioned step you can always skip. Grandma's recipes call for it, but flour looks fine straight from the bag, so why bother? Modern flour is pre-sifted at the mill, so it seems like a leftover ritual from a less refined era. Here's what's actually happening. Flour compacts and settles during shipping and storage, and sifting isn't just about removing lumps, it's about reintroducing air before delicate batters need it. For an angel food cake or a genuine sponge, that air is the difference between cloud-like and dense. Baking authorities like King Arthur still recommend sifting for these fragile builds specifically, even with modern flour. So the fact isn't totally wrong for everyday muffins, but for delicate cakes, skipping it quietly steals the lightness you were promised. Fact number 3. Opening the oven door always deflates your cake. Every home baker has been warned never to peek, like the cake will collapse the second light hits it. It feels like an unbreakable rule, whispered in every kitchen. But the real danger isn't light, it's temperature and timing. A cake with a set structure, meaning the proteins and starches have already firmed up, can handle a quick door open just fine. It's early in baking, while the batter is still a fragile foam of trapped gas, that a sudden cold draft can cause a collapse. Pastry chefs will tell you the real rule is timing, not superstition. Wait until at least 75% of the bake time has passed before you check. So the fact survives because it's half true at the wrong moment. And that's exactly what makes it so easy to believe. Fact number 4. Baking soda and baking powder are basically interchangeable. Just use whichever one's in the pantry. They're both white powders that make things rise, so swapping them feels like a harmless shortcut. Bakers do it all the time and figure it worked out fine. But these are chemically different tools doing different jobs. Baking soda is pure base, and it needs an acid, like buttermilk or brown sugar, to react and produce lift. Baking powder already contains its own acid, built in, so it activates with just liquid and heat. Swap one for the other in equal amounts and you'll either get a bitter, metallic taste from unreacted soda, or a batter that barely rises at all. That flat, oddly sharp-tasting cake you made once wasn't a fluke. It was baking soda with nothing to react against. Fact number 5. Brown sugar and white sugar are basically the same thing with a little color difference. People swap them without thinking twice, since they both sweeten and both dissolve. But brown sugar carries molasses, and that molasses isn't just flavor, it's moisture and acidity. Cookies made with brown sugar spread less and stay chewier, because that molasses holds onto water during baking. Swap in white sugar and you'll get a crispier, flatter, less complex cookie every time, even with an identical recipe otherwise. Serious Eats has tested this side by side repeatedly. The sugar you choose changes the physical chemistry of the dough, not just the taste. So that healthier swap you made once for sugar you had on hand actually changed the entire texture of what came out of the oven. Fact number 6. Vanilla extract and vanilla flavoring are the same thing, so grab whichever is cheaper. They sit next to each other on the shelf and smell similar in the bottle, but real vanilla extract is made by steeping actual vanilla beans in alcohol for weeks, pulling out hundreds of aromatic compounds. Imitation vanilla flavoring is usually a single synthesized compound, vanillin, built in a lab to mimic just one note of that complexity. In raw batter, the difference is subtle, but once heat hits it, real extract's complexity survives baking far better, while imitation vanilla can turn flat or slightly bitter. The FDA even has strict legal definitions separating extract from flavoring because they are, chemically, not the same product at all. Fact number 7. You have to cream butter and sugar until it turns pure white or you've done it wrong. Home bakers cream for ages, waiting for that bakery white color. Worried anything less means failure. But color isn't actually the finish line. The goal of creaming is incorporating tiny bubbles that will later hold gas from your leaveners. And that lightening in color is just a visual side effect of trapped air scattering light differently. Depending on your sugar, your butter's fat content, and your mixer speed, you can hit perfect aeration well before the mixture goes pale. Over-creaming past that point can actually incorporate too much air, causing cakes to rise fast and then collapse. So chasing a color instead of a texture might be quietly wrecking the structure you worked so hard to build. Fact number 8. Salt in a dessert recipe is only there for flavor, so it's safe to skip if you're cutting sodium. It seems logical, since salt makes savory food taste less bland, and desserts are already sweet. But salt does real chemistry in baking. It tightens gluten strands, making bread dough stronger and more elastic, and it slows down yeast fermentation just enough to prevent doughs from overproofing too fast. Skip it in bread, and you'll often get a weaker, gummier crumb and a dough that rises unpredictably. In sweets, salt also suppresses bitterness and sharpens how sweetness is perceived. So that pinch of salt in your cookie recipe isn't decoration, it's quietly controlling both structure and how sweet the final product actually tastes. Fact number 9. Old baking soda from the back of the pantry still works exactly the same as fresh. Since it's a shelf-stable powder, it feels like something that can't really go bad. But baking soda's power comes from an active chemical reaction, and that reactivity fades over time, especially once the box has been opened and exposed to air and moisture. A simple test settles it. Drop a spoonful into vinegar. If it doesn't fizz aggressively right away, its leavening power is already gone. Bake with it anyway and you'll get a dense, flat result with no obvious explanation, because the ingredient list looked completely normal. Most kitchens should be replacing baking soda every 6 months, not keeping the same box for years. Fact number 10. Bread dough needs exactly 2 rises, no matter the recipe or the weather. It's the standard instruction almost everyone learns first, so it gets treated like a fixed law of baking. But rise time isn't really about a rule of 2. It's about the dough reaching the right internal structure, which depends heavily on temperature, humidity, and the specific yeast strain. A warm kitchen might get dough there in half the standard time, while a cold one might need much longer, or even a third rest for enriched, heavy doughs like brioche. Professional bakers judge doneness with the poke test, watching how quickly an indentation springs back, not a stopwatch. Chasing an exact count of 2 rises regardless of your kitchen's conditions is how so many home bakers end up with either dense, underproofed loaves or collapsed, overproofed ones. Fact number 11. The longer you knead bread dough, the better the final loaf will be. It sounds like classic hard work equals good results logic, so bakers knead well past what any recipe calls for, assuming more effort can only help. But gluten development has a real ceiling. Kneading builds a network of elastic gluten strands that trap gas from fermentation, and once that network is fully developed, extra kneading doesn't add more strength. It starts tearing the strands you already built. Over-kneaded dough becomes tough, dense, and can even turn slightly grayish from oxidation. Most bakers use the window pane test, gently stretching a piece of dough thin enough to see light through it without tearing, as the real signal to stop, rather than an arbitrary number of minutes. Fact number 12. Yeast dies the instant it touches water even slightly above 100 degrees Fahrenheit. This one makes people terrified of killing their yeast, so they use lukewarm water that's barely warm at all, which actually slows fermentation down. Yeast is more resilient than that fear suggests. It starts to weaken noticeably above about 120 degrees, and it's fully destroyed closer to 140. Water in the low hundreds is actually the ideal activation zone, waking yeast up quickly without harming it. The real danger zone is much higher than most home bakers assume, closer to what would already feel uncomfortably hot to touch. So that overly cautious lukewarm water isn't protecting your yeast, it's just making it take its time. Fact number 13. The more you mix pancake or muffin batter, the fluffier the result will be. It feels intuitive, like more effort should equal more air and more lift. But in flour-based batters, mixing does something very different from whipping cream. It develops gluten. And gluten, past a certain point, makes things tough and chewy rather than light. Overmixed pancake batter produces flat, rubbery pancakes with tunnels running through them, not fluffy ones. The rule most professional bakers follow is to stop as soon as the flour just disappears into the wet ingredients, lumps and all. Those lumps look imperfect, but they're actually a sign you stopped at the right moment, before the gluten had a chance to toughen everything up. Fact number 14. Adding extra baking powder always means extra rise, so more is simply better. It seems like straightforward math. Double the leavening agent, double the lift. But baking powder produces carbon dioxide bubbles inside a batter that has a limited structural capacity to hold them. Add too much, and the bubbles form faster and larger than the batter's gluten and starch network can support. So instead of rising higher, the structure collapses under its own gas. Often after an initial dramatic rise, you'll also taste it, since excess baking powder leaves a distinctly bitter, metallic aftertaste. Recipes calibrate leavening amounts precisely against flour and liquid ratios. And going rogue with extra powder is one of the fastest ways to sink a cake that looked perfect for the first 10 minutes in the oven. Fact number 15. A single speck of egg yolk in your whites will permanently ruin your ability to whip them that day. This gets repeated with real intensity. Like one drop is an unfixable disaster. The core idea has some truth. Fat from yolk does interfere with whites forming a stable foam, because fat molecules disrupt the protein bonds that trap air. But ruin forever isn't accurate. A small speck can often be removed cleanly with the edge of the eggshell itself, and even a slightly compromised batch can sometimes still whip, just to a smaller, less stable volume. What actually matters more is the bowl. Any lingering grease on a plastic bowl, even from a previous wash, can sabotage whites more reliably than a tiny fleck of yolk ever will. Stainless steel or glass, wiped with a bit of vinegar, is the real safeguard. Fact number 16. Butter and margarine bake identically, so they're always a safe one-to-one swap. They look the same in the wrapper and both technically qualify as fat, but butter and margarine have different water content, different melting points, and different fat structures. Butter melts at a lower temperature and contains more water, which turns to steam and helps create flaky layers in things like pie crust or biscuits. Margarine, especially stick versions built for spreading, often melts differently and can produce a greasier, less structured result in laminated doughs. The flavor difference is obvious to most palates too, since butter carries genuine dairy complexity margarine can't fully replicate. In cookies, the swap is more forgiving, but in pastry work specifically, treating them as identical is a common reason results come out subtly, stubbornly wrong. Fact number 17. Your oven's temperature dial is always accurate, so if a recipe says 350, you're getting 350. Ovens display a number with total confidence, so it feels like a fact rather than an estimate. In reality, home ovens are frequently off by 25 degrees or more, sometimes a lot more, due to worn thermostats and inconsistent calibration. That gap is invisible until you compare it to a separate oven thermometer sitting on the rack. A cake baked in an oven running hot can brown to fast on the outside while staying raw in the center. And one running cool can leave you guessing why bake times never match the recipe. Professional test kitchens like America's Test Kitchen always recommend an independent oven thermometer, because the built-in dial is really just a suggestion, not a guarantee. Fact number 18. Chocolate only seizes up and turns grainy when water gets into it, never from heat alone. The water warning gets repeated so often that people assume heat is a separate, unrelated risk. But chocolate can also seize from being overheated too quickly, especially in a microwave without stirring between short bursts. High heat can scorch the cocoa solids and cause the fat to separate from the rest of the mixture, creating a grainy, broken texture that looks strikingly similar to water-seized chocolate but happens through a completely different mechanism. The fix for each is even different. Water seizing sometimes can be rescued by adding more liquid to smooth it back out, while scorched chocolate generally can't be saved at all. Treating keep it dry as the only rule ignores half of what actually goes wrong. Fact number 19. Dark and light-colored baking pans produce the exact same results, so pan color is just a style choice. It seems like a pan is a pan, as long as the size matches the recipe. But color changes how a pan absorbs and radiates heat. Dark metal pans absorb more radiant heat and can cause cookies and cakes to brown faster on the bottom and edges, sometimes before the center has finished baking. Light-colored or shiny pans reflect more heat, producing a gentler, more even bake. Bakers who consistently get overly dark bottoms on cookies are often blaming the recipe, when the real culprit is sitting right there in the pan drawer. Many baking guides now recommend lowering oven temperature by about 25 degrees when using dark pans specifically, to compensate for that extra heat absorption. Fact number 20. Chilling cookie dough before baking is a pointless extra step that just delays dessert. It feels like stalling, especially when the dough already looks ready to scoop and bake. But resting dough in the fridge does real, measurable work. Cold butter melts more slowly in the oven, which means cookies spread less and hold a thicker, chewier shape. Chilling also gives time for flour to fully hydrate and for flavor compounds to develop further, the same way as to taste better the next day. Side-by-side tests from bakers like King Arthur consistently show chilled dough producing thicker, more evenly browned cookies with deeper flavor compared to dough baked immediately. So that extra hour in the fridge isn't wasted time. It's doing structural and flavor work you can't get any other way. Fact number 21. Parchment paper and wax paper work exactly the same way in a hot oven. They're both thin sheets of paper sold in similar aisles, so the mix-up is common and understandable. But only parchment paper is coated to be genuinely heat-resistant, capable of handling normal oven temperatures without a problem. Wax paper is coated in actual paraffin wax, which is not designed for oven heat at all. Put wax paper in a hot oven and that wax can melt, smoke, and potentially catch fire, while also transferring an unpleasant waxy residue directly onto your food. Wax paper's real job is for cold food prep, wrapping, and countertop surfaces, never the inside of a preheated oven. Reaching for the wrong roll out of habit is a mistake with a genuinely higher stakes outcome than most baking facts on this list. Fact number 22. High altitude doesn't actually change anything about how baking works. It's easy to assume a recipe is a recipe no matter where you live, since the ingredients and oven look identical. But air pressure drops significantly at higher elevations, and that pressure difference changes how gases expand and how quickly liquids evaporate. At high altitude, leavening gases expand faster and escape more easily, which can cause cakes to rise rapidly and then collapse, and it can cause moisture to evaporate faster during baking, leaving baked goods dry. That's why high-altitude baking guides recommend real adjustments, slightly less leavening, slightly more liquid, and often a bump in oven temperature to set the structure before it can overexpand. Bakers who move to the mountains and suddenly can't replicate a foolproof recipe usually aren't losing their touch, they're losing sea-level air pressure. Fact number 23. Flour lasts forever in the pantry since it's just a dry powder. Because it doesn't spoil the way fresh produce does, it feels immune to expiration entirely. But flour, especially whole wheat flour, contains natural oils from the wheat germ that slowly go rancid over time, changing both flavor and how the flour performs. All-purpose white flour lasts considerably longer since more of that oily germ is removed during milling. But it isn't infinite either, especially once open and exposed to air, heat, and moisture. Rancid flour won't necessarily look different, but it can produce baked goods with an odd, slightly bitter, or off flavor that's hard to pin down. Storing flour in an airtight container and refrigerating or freezing whole grain varieties meaningfully extends how long it stays reliable. Fact number 24. Sugar substitutes swap in for sugar at a 1-to-1 ratio with no other changes needed. Packaging often encourages this exact assumption, promising a seamless replacement, but sugar in baking isn't just sweetness, it's also moisture, browning, and structure. Many sugar substitutes don't caramelize or brown the way real sugar does through the Maillard reaction, leaving baked goods pale even when fully cooked. Some also lack sugar's ability to hold onto moisture, producing a drier, sometimes crumblier texture than the original recipe intended. Certain substitutes measure differently by volume too, since they're not chemically or physically identical to sucrose. A straight swap can technically work in a pinch, but expecting an identical result from a fundamentally different ingredient is where most substitute-based baking disappointment actually comes from. Fact number 25. Gluten-free flour blends are a direct 1-to-1 substitute for wheat flour in any recipe. It's an appealing idea, since the recipe stays otherwise unchanged. But gluten is the specific protein network responsible for elasticity and structure in wheat-based baking, and gluten-free blends have no equivalent protein doing that same job. Many rely on starches like rice flour, tapioca, or potato starch, often combined with a gum like xanthan to mimic some of gluten's binding effect, but the behavior still isn't identical. Straight swaps frequently produce crumbly, dense, or gummy results because the structural role gluten played simply has no direct replacement. Recipes specifically developed for gluten-free baking usually rebalance liquid ratios and add binders deliberately, which is exactly why they can't just be reverse-engineered from a standard wheat recipe. Fact number 26. If your dough feels sticky, adding more flour is always a safe fix. It seems like the obvious solution, since flour is what dries things out. But many doughs, especially bread doughs, are actually supposed to feel tacky and slightly sticky at certain stages. And that stickiness often resolves naturally as gluten continues developing during kneading or resting. Adding extra flour on top of the recipe's intended ratio throws off the entire hydration balance, and overfloured dough tends to bake up dense, dry, and tough instead of tender. Experienced bakers usually reach for a light dusting on their hands or work surface instead of adding flour directly into the dough itself. That instinct to fix sticky dough with more flour is one of the most common reasons home bread ends up heavier than the recipe ever intended. Fact number 27. If a toothpick comes out with a little wet batter clinging to it, the cake definitely isn't done yet. This gets treated as an absolute rule. So bakers keep the cake in longer and longer chasing a perfectly clean toothpick. But different textures on that toothpick actually mean different things. Wet, raw-looking batter does mean more time is needed. A few moist crumbs clinging to the pick, though, usually means the cake is actually finished, since carryover heat will continue setting the structure even after it leaves the oven. Chasing a completely clean, crumb-free toothpick every time often means overbaking, which is why so many home cakes come out drier than the same recipe made by a professional. The real target for most cakes is moist crumbs, not an immaculate, empty pick. Fact number 28. Every recipe should just be baked at 350 degrees, since that's the standard baking temperature. It becomes a kind of default setting people fall back on, even for recipes that specify something different. But 350 isn't a universal law. It's simply a common middle ground temperature that works reasonably well for a lot of cakes and cookies. Delicate items like meringues or custards often need much lower, gentler heat to set slowly without cracking or curdling, while things like puff pastry or pizza dough benefit from very high heat to create rapid steam and crisp layers quickly. Ignoring a recipe's specified temperature in favor of a default habit is a quiet way to sabotage results, especially for anything relying on precise, rapid heat transfer that 350 simply can't deliver. Fact number 29. Natural and Dutch processed cocoa powder are interchangeable, since they're both just cocoa powder. They look nearly identical on the shelf and both taste chocolatey. But they're chemically different. Natural cocoa is acidic, while Dutch processed cocoa has been treated with an alkalizing agent that neutralizes much of that acidity, giving it a smoother, darker flavor. That acidity difference matters enormously in recipes leavened with baking soda, since baking soda needs an acid to react with. Swap in Dutch processed cocoa where a recipe calls for natural, and you can lose most of your rise, since there's no longer enough acidity to activate the soda properly. This is exactly why some cocoa recipes specifically call for baking powder instead, sidestepping the acid requirement altogether. Fact number 30. Salted and unsalted butter can be swapped freely, since it's really the same butter with a little extra flavor. It seems like a minor seasoning difference rather than a real recipe variable. But recipes are calibrated around a specific, controlled amount of salt. And salted butter's sodium content varies noticeably between brands, sometimes by a significant margin. Using salted butter in a recipe that separately calls for its own precise measured salt can throw the overall balance off, sometimes making a final product taste unexpectedly salty or muting other flavors. This is exactly why most serious baking recipes default to unsalted butter, treating salt as its own separate, controllable ingredient rather than leaving it hidden inside whatever butter happened to be on sale. Fact number 31. You need a stand mixer to make genuinely good bread at home. It's an easy assumption in an era of powerful kitchen appliances, and stand mixers with dough hooks are certainly convenient. But bread has been made by hand for thousands of years, long before any mixer existed, using nothing but kneading by hand to develop gluten. Hand kneading takes longer and more physical effort, but it produces the exact same structural network a machine builds. Since gluten development is about mechanical action stretching proteins, not about which tool provides that action, many experienced bread bakers actually prefer hand kneading for smaller batches, since it lets them feel the dough's texture change in real time. A stand mixer is a convenience, not a requirement, and treating it as mandatory keeps a lot of capable bakers from ever starting. Fact number 32. Bread flour and all-purpose flour are essentially the same thing, so it doesn't matter which one you grab. They look and feel almost identical in the bag, but the real difference is protein content, and protein is what becomes gluten once water and kneading are introduced. Bread flour typically runs higher in protein, around 12 to 14%, producing a stronger, more elastic gluten network that helps bread rise tall and hold a chewy structure. All-purpose flour sits lower, generally around 10 to 12%, which works fine for many baked goods but can leave bread with a weaker structure and a flatter rise, in a pinch. All-purpose flour can substitute for bread flour reasonably well, but for a baker chasing that specific chewy, structured crumb, the protein difference is doing real, measurable work behind the scenes. Fact number 33. Freezing baked goods always ruins their texture, so anything frozen is automatically inferior. This gets repeated as an absolute, discouraging people from freezing perfectly good extras. But freezing itself isn't the problem, ice crystal formation is. When baked goods are frozen slowly, large ice crystals form and can rupture cell structures, leading to a mushier texture once thawed. Wrapped properly, airtight, with excess air removed, and frozen quickly. Many baked goods like cookie dough, muffins, and even whole cakes freeze remarkably well, with minimal texture loss. The real culprits behind ruined frozen desserts are usually improper wrapping, letting freezer air dry things out, or slow, gradual thawing that lets moisture redistribute unevenly. Freezing done correctly is a legitimate preservation tool, not an automatic downgrade. Fact number 34. All vanilla extract is roughly the same strength no matter the bottle or the brand. Since the label just says vanilla extract, it seems standardized. But extract strength depends heavily on how it was made, how long the beans steeped, the bean variety used, and even the alcohol base. Some artisanal extracts are noticeably more concentrated and aromatic than mass-market versions, and double or triple strength extracts exist specifically for bakers who want a more pronounced vanilla presence. Using a weak, watered-down extract in a recipe calibrated for a stronger one can leave desserts tasting oddly flat despite following the recipe's measurements exactly. Vanilla is one of the few ingredients where the specific bottle in your cabinet genuinely changes outcomes, not just brand loyalty or price. Fact number 35. Cast iron pans are strictly for savory cooking and have no place in dessert baking. It's a reasonable sounding assumption, since cast iron gets associated with steak and cornbread, not cake. But cast iron's core property, exceptional heat retention and even distribution, is just as useful for desserts. Skillet cookies, upside-down cakes, and deep dish fruit crisps all benefit from cast iron's ability to hold steady, even heat and produce a deeply caramelized, crisp bottom crust that's genuinely difficult to replicate in a standard metal pan. The main caveat is seasoning and acidity, since very acidic fruit fillings can react with an underseasoned cast iron surface over long cook times. Used properly, cast iron is a legitimate dessert tool, not an off-limits savory-only piece of equipment. Fact number 36. Candy thermometers are only useful when you're actually making candy. The name itself sets up that narrow assumption, but a candy thermometer is really just a precise tool for tracking sugar syrup and liquid temperatures, and plenty of non-candy baking depends on exactly that kind of precision. Meringue-based buttercreams require hot sugar syrup brought to a specific stage. Caramel sauces, pralini, and even properly tempered chocolate all rely on hitting narrow temperature windows where a few degrees make the difference between success and a grainy, seized mess. Bakers who avoid buying a candy thermometer because they don't make candy are often unknowingly guessing at temperatures that a $5 tool would nail precisely, every single time, without any trial and error. Fact number 37. Whipped cream doesn't care whether the bowl or cream is cold, since whipping is just mechanical air incorporation. It seems like temperature shouldn't matter for something that's essentially just physical agitation. But cream whips by trapping air within a network of fat globules, and fat holds its structure far better when cold and firm rather than soft and near melting. Warm cream's fat is too fluid to hold air bubbles stable, so it takes much longer to whip, and the resulting foam is often less stable, deflating faster once made. Professional bakers routinely chill not just the cream but the bowl and whisk attachment beforehand specifically to speed this process and produce a firmer, longer-lasting whip. That extra 10 minutes in the freezer isn't superstition, it's directly exploiting how fat behaves at different temperatures. Fact number 38. Overproofed bread dough is always ruined and has to be thrown straight in the trash. It's treated as a point of no return, especially by anxious first-time bread bakers. But dough that's overproofed, meaning the yeast has produced more gas than the gluten structure can hold, can often be rescued rather than discarded. Gently deflating the dough by hand and reshaping it allows some of that excess gas to escape while giving the gluten network a chance to reset and rise again, often with better structure the second time. It won't always produce a perfect result, and severely overproofed dough with a truly collapsed structure may be a lost cause, but a slightly puffy, over-risen dough is frequently salvageable with a simple reshape and a shorter second rise, not an automatic loss. Fact number 39. Muffins and cupcakes are the same batter, just baked in a different pan. They look nearly identical sitting side by side and use overlapping ingredients, but they're actually built using two different mixing methods entirely. Muffins traditionally use the muffin method, quickly combining wet and dry ingredients with minimal stirring to intentionally limit gluten development, producing a coarser, more tender crumb. Cupcakes typically use the creaming method, the same butter and sugar aeration technique used for cakes, producing a finer, softer, more cake-like texture built for holding frosting. Mixing a muffin the way you'd mix a cupcake, or vice versa, produces a noticeably different, often disappointing texture, even with a near-identical ingredient list. The pan shape is a coincidence of size, not the defining difference between the two. Fact number 40. Butter and oil can always be swapped 1-to-1 in any recipe without changing anything else. Both are fats, so the substitution feels logically sound on paper. But butter is roughly 80% fat and contains water and milk solids, while oil is nearly 100% fat with no water content at all. That water in butter turns to steam during baking, contributing to rise and structure in ways oil simply cannot replicate. Oil, on the other hand, stays liquid at room temperature, which is exactly why oil-based cakes often stay noticeably moister for longer than butter-based ones, since butter resolidifies as it cools. Swapping between the two changes texture, moisture retention, and even how quickly a baked good stales, not just the fat source in the ingredient list. Fact number 41. Baking is basically just like cooking, so you can eyeball measurements without much consequence. Confident home cooks often carry this instinct straight into baking, used to adjusting seasoning by taste and feel. But cooking is largely forgiving chemistry, adjustable in real time, while baking is closer to a fixed chemical reaction, set in motion the moment it enters the oven with no way to taste and correct along the way. Ratios of flour to liquid to leavening are precisely balanced to produce a specific structural outcome, and eyeballing even a modest deviation can throw off gluten development, rise, or moisture in ways that only become obvious once it's too late to fix. This is exactly why professional bakers weigh ingredients on a scale rather than relying on volume measurements or instinct, treating baking recipes far closer to a laboratory formula than a loose cooking guideline. Fact number 42. A cracked cheesecake means the entire dessert is ruined and inedible. A crack across the top looks alarming, like something has gone catastrophically wrong. But cracking is almost always a cosmetic issue, not a structural or safety one. It typically happens from rapid temperature changes, overbaking, or the cake being pulled from a springform pan's sides too aggressively while cooling. The custard base underneath is generally unaffected in taste or texture. Professional bakers routinely mask cracks with a topping, a fruit compote, or whipped cream rather than treating them as failures at all. Techniques like baking in a water bath and cooling gradually with the oven door cracked open dramatically reduce cracking. But a crack that does appear anyway is rarely a reason to throw the whole cheesecake away. Fact number 43. There's no real substitute for buttermilk if a recipe specifically calls for it. It has a distinct tang that seems hard to replicate with anything else in a typical kitchen. But buttermilk's key functional role in most recipes is its acidity, which reacts with baking soda for lift and also tenderizes gluten strands. A simple, well-known substitute exists: adding a tablespoon of lemon juice or white vinegar to a cup of regular milk, letting it sit for a few minutes to curdle slightly, closely mimics buttermilk's acidity and consistency. It won't perfectly replicate every nuance of cultured buttermilk's flavor, but functionally, in terms of the actual chemistry the recipe depends on, it performs almost identically. This substitution is common enough that it appears in most major baking references, not some obscure workaround. Fact number 44. Meringue absolutely cannot be made without cream of tartar, so skip it and you're out of luck. Cream of tartar gets treated like a mandatory ingredient rather than a helpful additive. In reality, it's an acid that stabilizes egg white foam by helping the proteins bond more securely, producing a more forgiving, stable meringue that's less likely to collapse or weep. But it isn't strictly required. A small amount of lemon juice or white vinegar provides similar acidic stabilization, and even meringue made with no acid at all can succeed with a clean, grease-free copper or stainless bowl and careful technique, since copper bowls have their own natural stabilizing chemical reaction with egg whites. Cream of tartar makes meringue more forgiving, not possible in the first place. Fact number 45. Cookies and cakes can be stored together in the same container with no consequences. It seems like harmless space saving, since they're both just baked goods sitting in a tin. But different baked goods have different moisture contents, and storing them together allows moisture to migrate from the more humid item to the drier one. A moist cake stored next to crisp cookies will often make those cookies go soft and stale faster, while the cookies can pull moisture away from the cake. Drying it out prematurely, flavors can transfer too, especially with anything containing strong spices or citrus. Bakers who keep items separated, especially crisp versus soft textures, generally get significantly longer shelf life out of both, rather than one dessert quietly sabotaging the other in a shared container. Fact number 46. Sugar's only real job in a recipe is providing sweetness, so cutting it down should be harmless. It seems like a safe way to make a dessert healthier without changing much else. But sugar performs several structural roles beyond taste. It attracts and holds onto moisture, keeping baked goods tender and slowing staling. It contributes to browning through caramelization and the Maillard reaction, giving baked goods their color and complex flavor. In some recipes it also affects how much air gets incorporated during creaming, since sugar crystals are what cut those air pockets into butter in the first place. Cutting sugar significantly without adjusting anything else often results in paler, tougher, faster staling baked goods, not just a less sweet version of the same thing. Fact number 47. Mold growing on bread means the yeast inside is somehow still alive and actively growing. This mixes up two completely different organisms doing two completely different things. The yeast used to leaven bread is fully killed during baking, since oven temperatures far exceed what any living yeast cell can survive. The fuzzy growth that later appears on stale bread is an entirely separate organism. Airborne mold spores that landed on the bread's surface after baking and found the right moisture and warmth to colonize. It has nothing to do with the original yeast reactivating. And unlike some hard cheeses where you can simply cut around mold, bread's soft, porous structure allows mold's root-like threads to spread invisibly throughout the loaf, which is exactly why food safety experts recommend discarding the entire loaf, not just the visibly moldy slice. Fact number 48. Baking soda can always replace baking powder in equal amounts if you're out of one. This mistake usually comes from fact number 4's confusion resurfacing in a slightly different form. Baking soda is roughly 3 to 4 times more powerful than baking powder by volume. Since baking powder is partly made of cornstarch filler and only a portion active leavening agent, swap in an equal amount of pure baking soda and you'll wildly over-leaven the recipe, producing a bitter, metallic taste and a batter that rises too fast before collapsing. If you truly must substitute, the real ratio involves using roughly 1/4 to 1/3 as much baking soda as the baking powder called for, plus adding an acid for it to react against. A 1-to-1 swap here isn't a minor adjustment, it's a completely different chemical outcome. Fact number 49. Every spot inside your oven bakes at exactly the same temperature. The dial shows one number, so it seems reasonable to assume uniform heat throughout the whole cavity. But ovens have real, measurable hot spots and cool spots, caused by heating element placement, airflow patterns, and even where the door seal is strongest or weakest. This is exactly why a tray of cookies can come out browner on one side than the other, or why bakers are advised to rotate pans halfway through baking. Convection ovens with a built-in fan help even this out considerably by circulating air, but standard ovens can vary by a surprising number of degrees from one side of the rack to the other. Ignoring this uneven heat is one of the most common, invisible reasons a single batch bakes inconsistently despite using one uniform batter. Fact number 50. Adding extra eggs to a cake recipe always makes it richer with no real downside. Eggs are strongly associated with richness, so more eggs feels like a straightforward upgrade. But eggs provide structure as much as richness, since egg proteins set during baking and help hold a cake's shape add significantly more than a recipe calls for, and that extra protein can make the final texture noticeably denser, chewier, or even slightly rubbery, more like a custard than a light cake crumb. Eggs also add liquid, and extra liquid without a corresponding increase in flour or leavening throws off the entire structural ratio the recipe was balanced around. A recipe's egg count isn't just a suggestion for richness, it's a load-bearing structural variable that a few extra for good measure eggs can quietly undermine. Fact number 51. It's fine to frost or ice a cake while it's still warm from the oven, since the frosting will just melt in a little. It seems efficient to skip the wait entirely. But warm cake radiates enough heat to genuinely melt buttercream and other fat-based frostings, causing them to slide off the surface instead of holding their shape, and in extreme cases pooling messily around the base of the cake. Beyond appearance, warm cake also continues releasing steam as it cools, and trapping that moisture under a layer of frosting can make the cakes crumb gummy in the areas closest to the surface. Most baking guides recommend cooling the cake completely, often for a full hour or more depending on size, specifically to prevent both of these outcomes. That impatient extra 10 minutes of waiting is doing real, protective work for both texture and appearance. Fact number 52. A sourdough starter dies permanently if you miss just one scheduled feeding. This gets repeated with almost moral weight. Like neglecting a starter for a day is an unforgivable mistake. In reality, a mature, healthy starter is far more resilient than that. Missing a single feeding at room temperature usually just means the yeast and bacteria inside temporarily run low on food and become more sluggish or acidic. Not that they die outright. Starters can survive being neglected in the refrigerator for a week or more between feedings, and even starters that look discouraged, with a layer of dark liquid called hooch on top, can typically be revived with just a couple of consistent feedings. True starter death, meaning the yeast population is genuinely gone, generally takes sustained, severe neglect over a much longer period, not one missed day. Fact number 53. Store-bought puff pastry performs exactly the same as homemade every single time, so making it from scratch is wasted effort. Puff pastry does share the same fundamental principle either way, thin layers of butter trapped between dough that create steam and separation during baking. Quality commercial puff pastry, particularly all-butter versions, can genuinely perform very well and rise beautifully. But not all store-bought versions are equal, and many budget varieties use vegetable shortening or oil blends instead of real butter, which changes both flavor and how dramatically the layers puff and separate in the oven. Homemade puff pastry also allows control over thickness and lamination quality that mass production can't always match consistently. The fact isn't entirely wrong for premium products, but treating all store-bought puff pastry as interchangeable with genuine all-butter lamination overstates the case. Fact number 54. Bleached flour exists purely to make cakes look whiter, with no functional purpose beyond appearance. The name itself makes it sound purely cosmetic, but the bleaching process does more than just lighten flour's color. It also alters the protein structure and starch behavior of the flour itself. Bleached flour typically has a slightly weaker gluten structure and a finer texture, which is actually why it's often preferred specifically for delicate cakes, since it produces a softer, more tender crumb than unbleached flour would in the same recipe. Unbleached flour, by contrast, tends to have slightly stronger gluten development, making it generally better suited for bread and other structure-dependent baked goods. So the difference isn't just cosmetic whiteness. Bleaching changes how the flour physically performs in a batter, which is exactly why cake flour is so often bleached by design. Fact number 55. Skipping the chilling step for pie dough is fine as long as you work quickly enough. Speed feels like it should compensate for skipping refrigeration entirely. But chilling pie dough isn't primarily about temperature for its own sake. It's about keeping butter solid enough to remain in distinct pieces within the dough, rather than smearing into the flour. Those small, intact butter pieces are what create steam pockets and flaky layers during baking. Working quickly slows the process, but hand warmth and simple friction from rolling still soften butter meaningfully within just a minute or two of handling, regardless of how fast you move. Skipping the chill, even briefly, tends to produce a denser, less flaky crust, because once that butter has smeared into the flour, no amount of remaining speed can undo it. Fact number 56. Licking batter off a spoon or bowl containing raw eggs is basically risk-free, since it's such a common childhood habit. It's treated as harmless nostalgia rather than a genuine food safety consideration. Raw eggs, and raw flour as well, actually carry a real, documented risk of bacterial contamination, specifically salmonella in eggs and E. coli in raw flour, since flour is a raw agricultural product that hasn't been heat-treated before packaging. The odds of any single spoonful causing illness are relatively low, but they aren't zero, and the FDA specifically warns against consuming raw batter or dough for exactly this reason. Heat-treated flour products marketed specifically for raw consumption do exist now precisely because this risk is real, not imagined nostalgia dressed up as caution. Fact number 57. Non-stick spray means you never need parchment paper, since the pan is already coated. It seems redundant to layer parchment on top of a pan that's already marketed as non-stick. But non-stick spray and parchment paper solve overlapping but distinct problems. Spray coats a pan's surface directly, but that coating can wear thin in spots or interact unpredictably with certain sugary or high-fat batters, occasionally still sticking in patches. Parchment provides a completely uniform, physical barrier regardless of pan condition. And it also makes cleanup and removal of delicate items, like thin cookies or a full sheet cake, dramatically easier without risking a torn or stuck bottom. Many recipes actually call for both together specifically because they're solving slightly different problems, not because one makes the other unnecessary. Fact number 58. Powdered sugar and granulated sugar cream with butter exactly the same way. They're both technically sugar, so the swap seems inconsequential. But granulated sugar's coarser crystals are what physically cut air pockets into butter during creaming, and powdered sugar's much finer texture, along with the cornstarch it typically contains as an anti-caking agent, doesn't create that same abrasive aeration effect. Creaming butter with powdered sugar instead produces a smoother, denser mixture with noticeably less trapped air, which is exactly why powdered sugar is the standard choice for smooth frostings and glazes, but a poor substitute in recipes depending on creaming for structural lift. Like most butter cakes and cookies, the sugar type isn't interchangeable texture-neutral sweetness. It's a specific mechanical tool depending on the crystal size involved. Fact number 59. Doubling a recipe just means doubling every single ingredient in equal proportion. It feels like simple, safe math, since twice the serving should mean twice the ingredients. But leavening agents in particular don't scale perfectly linearly. Doubling baking soda or baking powder exactly can sometimes overleaven a larger batch, since the ratio of surface area to volume changes as quantities scale up, affecting how evenly gas escapes versus stays trapped. Bake time and pan size also don't scale simply either, since a doubled batter in a much larger pan bakes differently than the same total volume split across two normal pans. Professional bakers scale in recipes up often reduce leavening slightly below a straight double and adjust baking time and temperature deliberately, rather than assuming pure arithmetic will translate perfectly from a small batch to a large one. Fact number 60. Homemade bread doesn't really need salt, since it's only there for flavor and can be left out without consequence. This is the same flavor-only assumption as fact number 8, but it matters even more in yeasted bread specifically. Salt doesn't just season bread. It directly regulates yeast fermentation, slowing it down just enough to prevent the dough from rising too fast and developing weak, uneven gas pockets. It also strengthens gluten structure by tightening the protein network, producing a more elastic, better textured crumb. Bread made entirely without salt often rises unpredictably fast, develops an oddly loose structure, and tastes distinctly flat, even bland, despite having flour, water, and yeast in otherwise correct proportions. Salt in bread is doing structural and fermentation work that has nothing to do with taste alone, which is exactly why professional bakers treat it as a non-negotiable ingredient, not an optional seasoning. 60 facts down. If even a few of these explained a bake that went wrong for no obvious reason, you're not a bad baker, you were just working off bad information. Baking rewards precision more than instinct, and now you've got 60 fewer wrong instincts standing between you and a better loaf, cake, or cookie. Try one of these fixes on your next bake, and see